All right, so in this video, I'm wanting to show you something called the change of base formula. All right, it's just a way of evaluating logarithms for stuff that is kind of difficult. Like we should know what log base 2 of 8 is. To figure this out, it's just 2 to what power will give you 8. So the answer is going to be 3. All right, but something like log base 5 of 10 is quite a bit more difficult. We don't really know exactly what this is just in our brain because, we don't know what power to raise 5 to get 10 back as an answer. That's why. So what we're going to do is we're going to revisit our definition for logarithms, right? I want a different way of thinking about log base b of something, all right? I don't know what this is, so I'm just going to call it x, and I'm going to find another definition for this. So the first thing I'm going to do is I'm going to rewrite it in this form, in its exponential form. So b would be my base, x would be my exponent, and a would be my answer. Okay, now what I'm going to do is I'm going to take the log of both sides. Not log base b, just the log, all right? This could really be any base, all right? I'm going to do log of b to the x is equal to the log of a, all right? And again, this log, I'm using base 10, but it really doesn't matter what base we use here. Just common log is what we do because it's the most common. All right, what I'm going to do here is bring this exponent down using my third property. It's my exponent property for logarithms. When you have the log of something raised to an exponent, you can bring that exponent down and multiply it by the log. Okay, log A. All right, now I'm going to divide both sides. I'm solving for x, by the way. That's what I wanted to figure out. I'm going to divide both sides by the log of b here to cancel that out. Log b, bam. And so x equals log a over log b. Okay, x equals log a divided by the log of b. And this will be the case no matter what base you're playing with. So I could do this in log base 10, or I could do it log base e, any base, doesn't really matter. So let's revisit this problem over here again. If I want to do the log base 5 of 10, let's see here. My a is going to be my 10, so I need to do the log of 10 divided by the log. My base was 5, so divided by the log of 5. And when I divide these two, my regular log button right down here, log 10 divided by log 5, I get 1.43, and that's what x is. So that's what log base 5 of 10 is. 1.43067. All right. So if you do 5 to this power, you're going to get 10. That's called the change of base formula. It's pretty handy when you're evaluating funky logarithms.